Okay, so problem three. Problem three is your classic intro to structural engineering problem. It's a problem that appears on every single year of homework assignments, and only a couple of things change every time, just a couple of numbers. So very similar to problem two, you're going to have to analyze the internal axial forces as well as the internal moment forces for each of these members. So in other words, the first thing you want to do is draw your axial force diagram, draw your shear force diagram, and draw your moment diagram. Once you have that, for frames, you always have two components. You have deflection due to axial and deflection due to moment or due to bending. You need to take both of those into account, which is why you're given both E and A. In this case, if I'm trying to find the axial force, I treat it just like I did when I was doing my if you're trying to find axial force, pretend this is a truss. Right? Just pretend that it's a truss. Find the axial force in this member, find the axial force in this member, find the axial force in this member. Draw that out in your diagrams. So for example, my diagram for this might look something like, and I haven't checked this yet, so this is just purely guessing here, just as an example. But let's say, for example, that this was in compression. Let's say that this was in compression, and let's say this was in tension, for example. I would get values here. So I would get some value for this. Let's say this was like 10 kilonewtons or something. And let's say this one was like 15 kilonewtons or something. And this one was like 5 kilonewtons. I would do the same thing as I was doing for problem 1 and 2. I would generate my table. So I would generate my my member, my FP, my FQ, my L, my A, my E, my product. I would add all those two together. So I would do the FP, FQ, AE. I missed an L in here, right? I would do my product. I would add those all together, and that would give me my delta axial. Again, my Q system, I just apply unit load at the point I'm interested in. In this case, I'm interested in the horizontal displacement at A and the horizontal displacement at C. Therefore, my first Q system, I'll apply horizontal displacement of 1 at A. Right, I'll just apply horizontal displacement. I'll do the same thing. So this is my Q1 diagram. My Q2 diagram would be horizontal displacement at C. I would just apply a unit load of 1 here. I would find out what the axial forces are due to this member, axial forces due to this one, moment due to this one, moment due to this one, and I would record those as well. Okay. For the moment, you should have been given a, well, I don't know if you've been given this table yet. You should be given a table that relates your MP and your MQ diagrams. So let me see if I should have found that table before I started the video, but yeah, let me pause this for a sec. Okay, sorry for the interruption. I don't know if I'll be able to merge these two videos together. My actual experience with editing videos is extremely limited, so I might just upload this as a second video. But the chart I was trying to find was this chart, and I'll see if I can upload this onto LMS. I think the professor will definitely make this available to you at some point. But the idea is that I just need to find the shapes of my moment diagrams. So for example, if you look at this diagram here, all of my loads, I have no loads in between the 2 points, right? And I only have point loads being applied to my frame. That means my shear loads my shear diagrams will be rectangular at all times. Therefore, my moment diagrams will all be triangular or trapezoidal. Right, so for example, sorry, I should backstep here a little bit. When I apply this unit load, I'm going to get some axial forces All right. I'm also going to get some. I need to calculate my moment. So I applied my virtual force. I needed to find the axial forces in each one of my members. I need to draw the axial force diagram. I also needed to draw a moment force diagram for each of my members. My moment force diagram might look something like this. Right? This is a rectangle, a trapezoid, and a rectangle. Actually, let me get rid of this notation. So I would need to do that again here. And I also have my moment diagram from my original P system, right? I didn't write out my P system. I didn't actually solve for it, but you could imagine that I would get a P system that looks something similar to one of these, right? I would get a P system that looks something, I don't know, let's say that it's like this. Right, so let's say, for example, that my P system is a triangle, a rectangle, and a triangle. Instead of finding an equation for this one, multiplying the two of them together and integrating that, so instead of, I'm going to use this in a different marker here so that you know not to do this, I would normally have to take this times MQ times L, divide this all by E and I. And I would have to, so I'd have, MP would be a function of X, MQ would be a function of X. I have to multiply those together, integrate them, that'd be some long and complicated process. Instead of doing that, so I don't want to do this. Instead of doing that, I want to refer back to this table, the table that I was showing you earlier. That table allows me to just look at the shape of my moment diagram, and from there I can calculate this product immediately. Right? So what do I mean by that? If my P system was a triangular shape and my Q system was a triangular shape, right? Notice this is MP and MQ. If I had a triangular P diagram and a triangular Q diagram, I would go to the corresponding position in my table, and I would find out. I would use the values in here. Right? So my formula then is 1/3 M1 times M3 times L. My M1 is the largest value of my Q diagram, right? This is an M1 up here. I don't know if you guys can see that clearly. My camera screen is tiny, so I'm not sure how big this will appear on the actual video, but I have this M1 here. The moment at this point, of course, I plug that moment into here. My moment at this point, I plug that into here. So in other words, if I'm looking at, for example, this case, right, where I have two triangles, I would just take the heights of those two triangles and I would plug those in, right? So this one, let's say that this was my P system. This would be my M3. Or is it M3 or is it M2? M3. This would be my M2, or my M1, sorry. This would be L, this would be L. I would plug that into this formula. And that would give me this integral. Right, so my integral of my MP, MQ, and is L included? No, L is not included. So the integral of my MP times MQ. So in other words, MP represents the equation for this line. MQ represents the equation for this line. Both of those, sorry, MP is this line, MQ is this line. Both of those lines are linear, right? They're generating a line for a triangle, so it's not particularly complicated. But if I multiply those two together and integrate them, I would get this result. So this basically means that I can use this table to avoid any integration for moments. And you have a lot of shapes in here, right? So your Q system, because your Q system is just a point load, it will almost always be a rectangle. It would almost always be some kind of linear load like this, right? You'd always have a rectangular or a triangular moment diagram. right? This is just some combination of a rectangular and a triangular moment diagram. Your P system could be a little bit more complicated. That's why you have more cases here. But most, I would say, like almost all the problems you have in this course, you can refer back to this table. And all the problems on an exam that you would see, you can refer back to that table. So make sure you get very comfortable using this table. Once I have that, I need to do this for all three components, right? So this is 1 and 1. This was 2 and 2. This was 3 and 3. I would multiply 1 and 1 together, 2 and 2 together, 3 and 3 together. Add those together, just like I did for my axial force. So for example, I would generate another table. This one's going to be a little bit more different, but I would have my members in one column. My members, let's say this is A, B, B, C, and C, D. And then I would have my, let's say I would have my L, my EI, then I would have my MP, MQ. And then I would take my integral of MP, MQ on L on EI. That would be the last column. And I would just add all these together to get my deflection due to bending. Right, so as you can see, like for delta axial, I found the axial force in each one of these members. And I used that to find, so I had, in parts 1 and 2, I applied a virtual force, and I found the internal forces due to that virtual force. I had my external forces, and I applied my I found the internal forces due to those external forces. Right, I had my P system and my Q system. I'm trying to find my original sheet here. Alright, so problems 1 and 2, I had my axial forces, I had my P system, my Q system. For bending, I have the same thing, except I have both axial and moment. For moment, I find the moments in all three members. I refer back to this table now to find the actual formula that I need to use. And then I plug those values in. I solve for each one of these members. I've solved for member 1, member 2, and member 3. Sorry, let me zoom out. That's why I'm having trouble fitting everything on this one screen now. I get a result from member 1, I get a result from member 2, I get a result from member 3. I add all three of those together. That gives me deflection due to bending. I add those two together, and that gives me my total deflection at that point. So I have a feeling that I might have lost a couple of you during that process. But if you have any questions, feel free to stop by and see us. Oh, for the last part of that problem, it's exactly the same as the last part of problem 2. You need to apply, you're going to get a result. So again, using superposition, analyze this system, find the deflection at A, then analyze this system, find the deflection at A. Let's call this A1, A2. Right? This will have axial bending. This will have axial bending. This one will combine, right? It'll have deflection has consistent units, so this will have deflection of something in millimeters, this will have deflection of something in millimeters. This will be in terms of P. Do delta A1 plus delta A2 equal to 0, and solve for P. So it's exactly like what you're doing for problem 2. So again, let us know if you have any questions on this this problem.